So this video is going to extend what we learned about multiplication of polynomials. We're going to talk about special products. And these pop up enough throughout mathematics to warrant some special attention. And we have a few formulas here. So we have these things called perfect square trinomials. So if I square a binomial, and we learned how to square a binomial in the last video, if you square a plus b in parentheses, and you combine your like terms, you're going to get a squared plus 2a plus b squared. And it's not a bad idea to pause the video to double check these formulas. If I square a minus b, and again, there's parentheses around a minus b, I get a squared minus 2ab plus b squared. If you notice, the difference in the formulas is really just one sign. So when I'm squaring the a plus b, I'm going to get all of my signs positive. And when I square a minus b, that middle term is going to be negative, but negative b times negative b is a positive b squared. Okay, so these are special products, and they're special because they show up a lot, and getting comfortable with these is going to help you with a lot of things in future topics. The other special product would be the difference of squares. And that's when I multiply a plus b times a minus b. And when I multiply those out, the middle terms are going to cancel out, and I'm going to get a squared minus b squared. And with this one, I want to talk about a couple things. When I have a pair of binomials that look the same, but they're off by a sign in the middle, we call those conjugate pairs. And that's going to be really important when we talk about radical expressions and complex numbers. But for right now, if you could just memorize that, it's useful. We'll talk about it again later. And the other thing, there's no such thing as a formula for sum of squares. So you might be saying, well, what about a squared plus b squared? There's no special formula for that right now. And we'll address this multiple times in different contexts throughout these videos. Let's look at some examples. So if we're told to use the perfect square trinomial formulas, and I abbreviate that as PST, we should use those. If I'm wanting to know what x plus 7 quantity squared, and I know that, let me write this off to the side. Let's see here. I know a plus b squared is a squared plus 2ab plus b squared from our formula. How does this apply to a problem like this? Well, x equals a, b equals 7, x squared is a squared, 7 squared is 49, is b squared, and finally my 2ab, 2 times x times 7 is a 14x. So I can stitch these together. My a squared is x squared. My 2ab, we did the work off to the side, is a 14x. And finally, my b squared, which is 7 squared, is 49. And I'm done. And if I have something that looks like, say, xy quantity squared, or xy minus 3 quantity squared, different color here. I'm going to use my other difference of squares with subtraction. So a minus b squared is a squared minus 2ab plus b squared. And we're going to get A is xy. And when I square xy, I get x squared y squared. B is -3. So B squared is -3 times -3, which is a 9. And 2AB is 2 times xy times -3. And that's going to be -6xy. And so I can stitch my answer together by taking a squared, which is x squared y squared, which I did off to the side, minus 6xy and plus 9. And that is how I use the difference of squares. I'm sorry, the difference perfect square trinomial formulas to compute answers. Now, we're going to multiply using the difference of squares formula, and I have 2 examples. Let's look at x plus 10 and x minus 10. And we're going to recognize that a plus b and a minus b is a squared minus b squared. So we're not going to bother multiplying out to cancel out the terms. I'm going to recognize that my a is x, b is 10, and so x squared is x squared, and 10 squared is 100, and the formula has a subtraction in the middle. And so I'm going to get x squared minus 100. These can get a little bit uglier sometimes. So if I'm going to look at something like 2x squared minus 9y squared. Oh, scratch that. I'm kind of jumping ahead of myself a little bit. I'm looking at 2x minus 3y and 2x plus 3y. Sorry, I was starting to copy the solution. Okay, this is a difference of squares where my a is 2x and my b is 3y. So 2x quantity squared is a 4x squared. And 3y times 3y is 3y times 3y is a 9y squared. And that is separated by subtraction. And that is how we handle difference of squares. I'll see you in the next video.